Test, test, test. All right, welcome everybody to the afternoon sessions. You are in the methodological advances room. And so we'll have 3 talks this afternoon. I'm Kevin Rader. I'll be your chair for the session here from the Harvard Stat Department. But more importantly, our 3 talkers. Our first talk today will be given by Ron Yurko. Many of you may know him. He is an assistant teaching professor in the Department of Statistics and Data Science at Carnegie Mellon and is director of the Carnegie Mellon Sports Analytics Center. His research focuses on developing methods at the interface of inference and machine learning oriented towards problems in sports analytics and NLP. His work has been featured in popular media outlets such as The Athletic, 538, The Wall Street Journal, and The Washington Post. He is a 3-time degree holder from CMU with a bachelor's, master's, and PhD all in stat. He also has industry experience in both finance and professional sports. So Ron, please take it away.
All right, thank you. Can you hear me fine in the back? Is the mic good? Okay, so in case you were not aware, college football in America has changed a lot over the past decade. So just to begin, back in 2014, that was the official launch of the playoff era of college football. Just started with a 4-team playoff and it's expanded since. 2018 was actually this interesting innovation of the transfer portal. So student athletes could always transfer between schools, but they actually created this software application. So maybe there are real athletes in the room that understand and experience this. I am not such an athlete, but literally a software portal that made it easier for folks to transfer between universities. So that had a little bit maybe of a bump on potentially switching between schools. Then a lot of stuff has happened. So in 2021, we saw the massive sweeping changes of college sports. One thing was just post-COVID was the rule change that you could transfer as a first-time transfer switching between programs without having to sit out a year. So that led to, okay, athletes can now switch between schools. They don't even need to sit out when they do so. Then there was, of course, the big NIL changes. All right, so everyone in this room, I'm sure, has heard of NIL and this impact of being able to get endorsement deals, universities paying athletes. If you want to find out more, there's a great book by Bill Connolly called Forward Progress that came out recently. Goes into the full history. I recommend you read that and check that out. Then we've also had in 2024, recently, the immediate eligibility, no matter how many times you transfer. So you not even just don't have to sit out after the first time, you could keep switching. So what has this led to? Well, this has led to, along the x-axis here is time, and then the y-axis is the number of transfers observed in college football, just focusing on FBS, the top division in college football. And so what you can see here is, starting from the beginning of the playoff era, we see then in 2018 with that official launch of this application database by the NCAA, a little bit of this increase in transfers, and then of course in 2021 things blow up. All right, we're in this just perpetual free agency era, constant turnover, players changing, going on between schools. Now the question is like, okay, how do we model this, or what impact does understanding transfers and the changes in rosters have on predicting team performance from one year to the next? And as a little bit of a quiz question for you, does anybody know which schools have the fewest incoming transfers going into their program? Just shout it out. Clemson. Service academies, right. So, service academies, yeah. Army, Navy, Air Force, there are no transfers. But someone has also mentioned Clemson, right? And there's this famous quote, Dabo Swinney talking about, we don't need transfers, I got transfers out of high school. What's on the opposite side? Which schools have the most transfers? Colorado primetime, right? Deion Sanders. So 2022, before Deion Sanders took over, teams 1-11. Then Deion Sanders comes in, whole new roster, right? And then we see a little bit of the change, going to 4-8, 2023, and then we get to 9-4 in 2024. They even put up a statue for the guy after that season. But you don't just it's not that transfers leads to automatic success. Looking at other schools with high transfers count, you had UNC Charlotte The coach, I never heard of this guy until I looked it up. He has a terrible picture on Wikipedia. His name is Francis Biff Poggi. Saying that wrong, I know. Lots of transfers. Did not work out well. All right, they only won very few number of games. He ended up getting fired through that 2024 season. So Deion Sanders had success. Biff Poggi, not so much of a success story. Right? Now we have some other success stories at Texas State, where this coach come in, bring in high number of transfers, both of those first 2 seasons, ends up getting a nice big contract afterwards. Team wins 8 games. And then another big example last year that we saw was Indiana. So Indiana was a program that was kind of middle of the road. Cignetti comes in, ends up bringing in basically his entire roster from James Madison, and the team makes the playoff. Right? So this was different levels of success that could be observed, and that's not that, oh yeah, you're bringing in transfers, you're guaranteed to be a better program. It's just, well, you're probably going to be different. And so one of the ways of thinking about this was they took a look at, on the x-axis here, is the number of incoming transfers to a program. Each point represents a single program in a given year. I've colored the points by the year, and then the y-axis, this is the change in the Massey rating from one year to the next, right, going from the previous year. And so the Massey rating is just a public college football rating system. It's not based on any model. It's, I think, just score differential and strength of opponent in a way. So it's a very simple thing. And if you think about like when you teach linear regression, looking at residual plots and whatnot and diagnostic model assumptions, this is not constant variance. Right? We're looking at something where clearly we have this massive amount of variance in the change from rating from one year to the next, associated with much earlier years in this sample I'm considering of going from 2014 to 2024. And then we see this period of time where, oh yeah, this kind of coincides with NIL 2021, the variance drops big time. And then we see, okay, different levels of performance based on teams with different transfer counts. And maybe at the tail end, these ones that have massive number of transfers kind of have that bump up, but I don't look at this plot and go, oh yeah, I see a clear increase. Higher number of transfers leads to better performance. I see non-constant variance. Right? And want to think about, well, how can I capture that variance appropriately in types of statistical models that we use to represent team strengths and ratings? And so that takes us to the classic Glickman-Stern model, and I'm going to think of just a simplified version of this model, not going to think of week-to-week variation, but at its core, we have, at the outcome level, we're modeling the score differential in a single game between 2 teams, so Team I and Team J, during a specific year. All right, so again, I'm simplifying things by forgetting about the week, so there's no week index here. And so at this core, there's this mean that's a function of the difference in these 2 team ratings. And of course, there's a game level variation. And then this simple model that I'm thinking about for the difference in the team ratings, we have these latent strength parameters, the coefficients that you're ultimately going to estimate. And then we're just going to account for some constant home field advantage. And my co-author, Luke Benz, has a great paper about how home field advantage has changed over time. I'm not going into that for this work. And so in the most basic version of this model is a classic autoregressive model, Kalman filter, where you're looking at, okay, the team rating in time t+1 is just a nice autoregressive function of the team rating in the previous year times this autoregressive gamma, where we're going to say, okay, gamma is bounded, it's going to be between 0 and 1. And then there's this constant innovation variance. Right, this variance that describes how much variability you're going to observe in a team from one year to the next. So this distribution, this is the prior entering a season. Right, so this is where do we think entering into year t+1 does the distribution for this team's strength, where is it going to be generated from? Right, so in this basic way, this variance is the same for everybody in its most basic simple form. And this distribution down here is just the initial prior to get things going of the first draw of the teams, and you have a variance describing differences between team ratings. So the data I'm going to consider for this setting, I'm just focusing on the playoff era, so from 2014 to 2024. I'll talk about 2025 at the very end. I'm only considering regular season FBS games. And so when I do that, I'm not including any bowl games. If you know anything about college football, players are sitting out in bowl games. So the bowl season is very different looking. Rosters are very different because players are deciding, you know what, I'm going to play in the NFL. Why would I waste my time for this? To play in the Pop-Tart Bowl, for instance. No offense to Pop-Tarts. So I'm not going to account for any of that. I'm also going to treat all FCS teams the same. So anytime an FBS team plays an FCS school, it's like I'm just labeling all those FCS schools as a single FCS entity, right? And I'm not considering any between FCS matchups that I have. Right, and then I also was able to gather all sorts of roster information via this great package, CFB FastR, enables you to access the College Football Data API. If you have any interest in college football, I strongly recommend you check this out. So much data at your fingertips that you can take advantage of and play around with in various ways. Okay, so if you fit this model, you'll get like team strengths and how they could change over time. I'm not going to spend too much time on this plot. This is the type of hot mess you can make. This is just showing you, oh yeah, how have team ratings changed over the course of this period of time. And so some fun things I'll just mention. In the ACC, which is the Atlantic Coastal Conference that also includes schools from California, you have Clemson, which has this really high rating around like 2019, and they've just been gradually pulled down since. There's a lot of stories going on here. There's clearly far more than 10 teams in the Big Ten. But regardless of that, thinking about, okay, this is this assumption of constant between season variance, regardless of what's going on. We know that the game has changed. All right, we have had these rule changes. We've had NIL come in. So what impact does that have? And so the actual inspiration for this project came from when I was creating my class a couple years ago, and I read this paper by Mark on the stochastic volatility extension for this simple state space model. And the idea at this core is you can allow the variance, between season variance, to just change from one year to the next. It'll be centered around the previous one, but it could blow up, right, because of whatever could be going on at some point in time. I thought, well, that's pretty interesting. I wonder if this will do a good job at modeling what's happened in college sports, and maybe that could pick up on the weirdness and the craziness of NIL. So when I fit this model and look at it, what you're seeing here is, again, the x-axis is the incoming season, and so the y-axis then, and just as a caveat, all this is Bayesian. Right? I'm not telling you about the weekly formative hyperprior, the parameters and everything, priors. It doesn't matter for this talk, right? But everything's Bayesian. You're going to get credible intervals for everything. So what you're seeing here is 80% credible intervals for the innovation standard deviation, so that tau on the previous slide, where this is allowed to vary from one season to the next. And so what you could see here from 2015 to basically getting in towards the NIL era, it's a higher innovation standard deviation. And then we get to the NIL era and it drops, and it seemed to pick up again in 2024. Now the caveat to this is, yes, this aligns up with that plot I showed you at the beginning where I was looking at using the Massey ratings. But this makes the assumption that that between season variance is the same for every team. And we know at the beginning, well, teams are handling transfers, NIL, differently, right? And so I would think, well, I just don't have non-constant variance at the year level. I could have non-constant variance at the team level. And so all we're going to do here now is say, well, what if we set that innovation variance to be a function of team-level information in particular years? And so as a starting point, I'll have just like an indicator variable that says, am I in the NIL era? Right? Just a simple indicator, 2021 and later, because something's going on in the NIL era, and we'll just try to capture things that way. And then a very basic term that we're including in here is the effect of the number of transfers that you have incoming into the roster. And we looked at number of transfers, departing transfers, they're strongly correlated with each other, so I'm only including incoming into this model. So we're modeling the log of this variance. So this is on the variance scale, it's a factor change then, right? It's a log model, so take the exponential of it to get a factor change on what is going to happen on this innovation variance that we have. So again, this NIL era indicator, and then counting how many incoming transfers I have. For FCS teams, I just took the average because I'm just treating all FCS teams equally with each other. All right, so again, fit another Bayesian hierarchical state-space model with weakly informative priors for regularization, and then I could get these nice-looking distributions for my parameters of interest here. So ignoring the beta 0 intercept, that's analogous to just what was the classic Lichtman-Stern constant term. I have these beta transfers and the beta NIL. So this posterior distribution for beta NIL, if you notice, is negative, right? It's below 0. This is coming into that effect of, okay, we're in the NIL era. The variance, the between-season variance, describing how a team rating could change from one year to the next, has shrunk, right? And that's in that context of the rich getting richer in college football, right? If I know that Ohio State is probably the best team in 1 year, I'm pretty confident they're going to stay relatively good into the next year, right? Versus, and that could be the function of them being able to afford the best players in various ways. And then to offset this, though, we do have this transfers coefficient that is positive, right? It's small, but if you think about the scale of what this can accumulate to, right, the number of transfers that a program could have, it could end up offsetting then that negative coefficient up top there. And you could actually get, higher variance in that NIL era. And so we actually can observe this where I'm showing you then the credible intervals for the team level standard deviations during this period of time where Colorado 2023 is up top at the highest. And this is just the top 10 schools, picking up on some of those programs that I mentioned at the very beginning. And as a comparison, if I showed the bottom schools on the opposite side of the distribution, ignoring all the universities in between, we get all those service programs and Clemson there with no transfers in particular years. And then some other schools that pop in. Stanford 1 year decided to not have any transfers as well. Good old Iowa, Kirk Ferentz, he didn't like transfers for a period of time too. So again, this is differences in the level of between season variance that we could have. So practically speaking, what does that mean? Why do we care about this? So to demonstrate, if I think of the 2023 season, right, I have this posterior mean team rating for Clemson and Indiana. Right, so I have this distribution, I'm just collapsing it down to the median rating. And so ignoring then my full samples for the fact that I have a posterior distribution for all these terms and the variances, if I just think about, okay, first, put in some autoregressive shrinkage, apply it to get each of these teams to be shrunk towards 0. Indiana was already pretty much middle of the road FBS program, so they're staying near 0. Clemson gets pulled a bit towards 0. But now, knowing that, I'm going to account for transfers in my new evolution innovation model, my distribution, my prior distribution entering the 2024 season for Indiana and Clemson is going to vary greatly, such that Clemson's entire distribution entering the 2024 season is contained within the Indiana distribution, right? I had so much uncertainty based on this model about where Indiana could end up. Indiana could have ended up like Clemson, or Indiana could have ended up like a dumpster fire on the other side of things. But as it turns out, Indiana ended up pretty well and made the college football playoff. This is not based on any information about the 2024 year besides the number of transfers that we had. Right? And I can imagine this is a generative distribution. I could pick a team rating from this model, and maybe if I was simulating and forecasting, Indiana would have a better chance of finishing in the playoff under this model versus if I completely ignored capturing the between-season variance information via transfers. Now, I just don't have to stop there. I was curious about, well, what about positions? All right, we talk about positional value all the time in NFL modeling and how passing matters more than running and whatnot. So I was curious, well, what if you looked at the counts of transfers by different positions. So you have all the skill positions, and then going to linemen, and ST is special teams. I was shocked at how many long snapper transfers there are in the FBS. They do exist. So when I consider this, though, having then a separate coefficient for each of these positions, we can look at the resulting posteriors, and what you get, defensive backs, defensive linemen, pretty good evidence that, oh, more defensive back, defensive linemen are associated with a higher between season variance. Some of these other terms, linebacker, it's just centered around 0. Offensive lineman, tilting a bit negative, but still includes 0. QBs, running backs are leaning positive. Same with wide receivers, but the incredible intervals are going to contain 0. Something that was interesting was tight ends and special teams, where especially tight ends here, it's really pointing on the negative side, meaning for whatever reason, schools that are getting tight end transfers are associated with having a lower between season variance. So there are problems with this model. I'm not accounting for whatever types of players some programs might be selecting for, right? I'm just treating this in a very naive way. So one of the things that we're still thinking about that's ongoing is how the hell do you evaluate this thing appropriately? Before I get to that, I forgot I included this, a little bit of the leaderboard of when you have positions in here. So similar in terms of what I had before, but some other big name programs actually jumped up in terms of this between season variance. Ole Miss, USC. USC in 2022, if you remember, that's the Caleb Williams year, so there was a lot of players that moved over from Oklahoma into USC following the head coach. I believe that was Oklahoma, right? Someone could correct me if I'm wrong about that. Thank you. But Ole Miss is not a program, this is where Lane Kiffin has been coached for a number of years now, very targeted types of transfers. And maybe that slide that I just showed you, a little bit on the same type of thing of if I want to get new players, I should probably focus on pass defense more than anything. And maybe that could be, now I'm not saying it's good or bad, I'm saying it's going to be bigger swings of what could happen from one year to the next. But going to this question, I'll show you the bottom 10 here. Some programs can be negative. South Carolina, they had tight end transfers and whatnot. But going to this question of how do we evaluate this, I thought about doing just the type of like holdout analysis, predictive performance, where it's a little bit tricky because I'm not modeling the mean, right? I'm modeling the between season variance. So things like the RMSE, they're not going to really be as affected as much. Like if I'm thinking about predicting the out-of-sample score differential for games. We can look at taking something like the ELPD and thinking about the holdout likelihood of whatever that score differential distribution could be for the models. And so I consider this of, what if I train based on all these years and predict on some holdout seasons? And I decide to only do 2023 and 2024 because I'm only really interested in the NIL era, right? I don't care about trying to predict this in 2021 or 2022 because this thing is relatively new. And what we're going to end up seeing here, and as a context, I'm doing this in a fully posterior predictive way where I'm actually going to just straight up sample a rating from that distribution, that posterior distribution I have entering a season. All right, so this is going to allow me to really have propagate all of that uncertainty in whatever predictions I end up generating. At the end of the day, what we observe is that the simplest model, the Glickman-Stern model, wins in terms of best predictions. And what I'm showing you is just one plot here where I have the 2023 season on the left and 2024 season on the right. And this is the difference in the ELPD for the model with transfers versus just the classic simple Glickman-Stern model. And so a positive value here would be great. It would be like, oh yeah, the transfer model is winning. We don't see that. We see that it's worse in 2023. But it's basically the same in 2024. The stochastic volatility extension model was by far the worst of the four. So there was some evidence to point like, yeah, transfers are a little bit useful. And if I only consider like an in-sample fit, then I have evidence saying that the transfer model is actually better in sample during that NIL era. All right, so I have some indication that maybe this is more appropriate. I wouldn't bet with it though. All right, and still thinking about how can I evaluate this in the sense of I care about this between season variance, and maybe it's about just seeing, oh, what's more aligned with bigger swings in the team's outcome from one year to the next. And that's what we just really want to capture, right? We want to have a model that can pick up on the capability of Indiana or another, or also pick up on a total disaster in swings of what we could observe. Okay, so hopefully what you've seen from this is we are capturing something about changes in the variance of what could happen from a team's performance from one year to the next, with evidence that in the NIL era, on average, it is lower. But if you accumulate a bunch of transfers, that could offset this. You could have more variance. And I don't think that's necessarily novel knowledge. This is something people have said of, oh yeah, transfers coming in, anything could happen. Right? And this is definitely correlated with new coaches. Right? A new coach comes in, they effectively have a new roster now. Right? You're going to have a new team when you bring in a new coach. Very much different from prior to the transfer portal era. And the thing I'm not capturing at all here is, what is the selection bias that could exist in the transfers? Because I don't have any information about the quality of those players. Is Ohio State, they're not getting that many transfers, one, because they don't need to. Their overall talent's potentially much higher. But of the transfers that they're targeting, right, are they selecting the best transfers, right, versus what other programs might bring in, UNC Charlotte. And I'm ignoring recruiting information here. I'm thinking that's only just going to hopefully be absorbed via that latent strength parameter that's getting modeled. And again, I don't have any information about the actual NIL amounts. And surely that would be correlated too with thinking about the quality of the player in some way. But I just want to emphasize here that this is still very limited data, right? This just started in 2021, and it's probably going to change in the years ahead. There's been constant conversations like, oh, should there be a commissioner and whatnot. So this is still very much early, but I do think that we're picking up on something, at least, of changes in what could happen from one year to the next. And I only modeled the variance. We've had some conversations of, does it make more sense to model something at the mean level and the change in the autoregressive parameter? Potentially. I think it's a lot more difficult, though. These models fit wonderfully, no problems, everything looked beautiful, no divergences. So I'm leaning towards sticking with this, but it's something else to potentially consider. So 2025. If you've been paying attention at all, there's been a number of schools with changes. I'm not going to show you the credible intervals of what the variances are, but just what were some of the leaders in transfers entering this year. And they're a bit all over the place in terms of the performance. Purdue and UNLV, this year's Purdue coach was UNLV's coach. So they got their new coach, and they've already improved technically upon 2024. UNLV, where the current Purdue coach, he was someone that was constantly bringing in many transfers each year. They got a whole new team effectively. Then we have some other things that could potentially be a disaster if you know anything about what's going on in UNC. And then Oklahoma State did not go so well recently. The head coach was just fired. So again, the story of you're bringing in transfers, it could be good, it could be really bad. We don't know. We're just going to find out as this progresses each year. So with that, just want to thank co-author Luke Benz as well as Tom Bliss for his expertise on this problem. And with any remaining time, take questions. Thank you.
Great. Thanks, Ron. Any questions? We have time for a few. Hopefully it's on.
All right, great talk. First of all, go Cyclones 2024 Pop-Tarts Bowl champs.
There you go.
I was wondering, I know the Caleb Williams effects he followed his coach, or Travis Hunter and Shedeur Sanders, they followed Deion Sanders to Colorado. Do you think that there would be an effect for players who transferred because they wanted to keep playing for a specific coach?
Yeah, that's a really interesting thing. And we could look at that because, thinking of UNC, he's not someone that brought players with him. Yeah, that's an interesting point. It's something I could actually look at. It's a good idea.
Yep.
Yeah.
Hi, my question's kind of similar. I was wondering if you would possibly be able to separate like between schools that are mainly getting transfers from like one singular coach bringing players with them. They might see like an improvement in performance versus schools that might be getting a lot of transfers because they lost their players, so they're actually like in the negative, and then they need to take transfers to compensate for that. Do you think there would be a difference in performance?
Yeah, it's an interesting idea. The one thing I don't know is when the transfers happen. All right, so I'm only dealing with, I know that transfers have taken place from one year to the next, but I don't know the order of which it took place. You're absolutely right that maybe there are programs that, they got depleted, they lost their best players. And that itself could be indication that things could be going more towards the bad end because they just had to find who is there to replace them with. But yeah, this is just, I know what was the end and versus the beginning rosters from the different years. So I can't account for that directly. It's a good idea, though.
Unfortunately, I think we're out of time, so thanks, Ron.
Yes.